Hello guys, welcome back to a new session in chapter 7. In today's session we'll be talking about the balancing redox reaction. In the first section we introduced the oxidation reduction halves and we talked about the oxidation number, which are basic for balancing the redox reaction. Guys, in order to balance the redox reaction, we have to follow 7 rules or 7 steps in order to balance the redox reaction correctly. And then the tips to balance we'll be talking about those steps, but we have to know something about the balancing. Here the balancing of redox reaction is not all about the balancing the mass of the atoms. Instead we have to balance both atoms and the charge as well. So we have to do balancing for the masses, for the number of the atoms in reactant and product, and then balance for the charges as well. So in this section we'll be balancing for both we'll be able to balance the charges and the mass of the atoms in order to know that both are conserved. What we have to do first balance the atoms and then the charges. So we have to take the priority for balancing the atom first and then the charges. Half reaction method. This method is the method that we follow to balance the redox reactions. In balancing redox reaction, we have to follow the 7 steps. A half reaction method is what is ion electron method for balancing redox reaction, consists of 7 steps. Is a method which we call, the half reaction method or ion electron method, which includes 7 steps. Example, balance the reaction of hydrogen sulfide and nitric acid to produce sulfuric acid, nitrogen dioxide, and water. Guys, in balancing the redox reactions, we have to determine, we have to first know the medium is in which medium. It's required to balance in which medium. It's very important to know the medium which the reaction we will be balancing the reaction in it. Acidic medium and basic medium. We have got 2 mediums, acidic and basic medium. How to know if it's not given the medium is acidic or basic? Usually, if in the redox reaction, we have got acids, that means it represents acidic medium. If alkaline the basis appears in the reaction, means it's basic medium. Or the question may ask you to balance the reaction in which of those mediums. What to do in the mediums? What are the differences of balancing in those mediums, guys? We will be talking about that, the mediums. To balance atoms, guys, to balance the atoms, we have to know the medium, acidic medium, and then we have basic medium. What to be added in acidic medium? We add H2O and hydronium, or we can say H2O and proton, H positive. How to add H2O and H positive? Use H2O to balance oxygen atom, add the number of water molecule equals the difference of oxygen in reactant to product. How many water molecule must be added? The number of the oxygen from reactant to product, the difference is what? We have to add the same number of the H2O. To which side must be added H2O? There is no difference in oxygen number, means atoms are balanced. If there is no difference between oxygen, it means the oxygens, the reaction in terms of atoms are balanced. For balancing the hydrogen, what should be added? Proton. Add twice amount as water molecule to the other side. we have to add the water to which side and the proton to which side? Guys, we add water to the side that contains the lower oxygen. We add water to the side that contains low oxygen. For example, in the above case, have a look on this half reaction. How to balance this half? Here I am balancing this half to show you how to use this technique of addition H2O and proton to the sides. As I told you, we have to add H2O to the number of H2O, which is equal to the difference of oxygen from reactant to product. To which side? To the side with the lower oxygen number. And then proton, how many protons should be added? Twice as the number of the H2O. If we add 2 H2O, we have to add 4H. If 4H2O, 8H must be added, and so on. To which side H must be added in the acidic medium? To the side which there is a high oxygen number. Guys, have a look on this half reaction. Do we have oxygen in the reactant? No. So the number of oxygen here is 0. How about how many oxygen in the product? 4. Is there difference between the oxygen number from reactant to product? Yes. How many differences? 4 oxygen is indifferent. What do we have to add for the reactant? What we have to add for the product? We have to add H2O to the side with the lower oxygen number. So how many H2O must be added? Equals to the difference between the oxygen number from reactant to product. 4 H2O must be added for the reactant. With the addition of 4 H2O, add how many H for the product or the higher oxygen side? Twice as the H2O. How many H2O we added? 4. So add 8 proton to the other side. 8 proton to the other side. But guys, sometimes check whether the compound contains more hydrogen, more proton or not. Here, because we added 8 proton to 4 H2O, and we have to add another additional 2 proton to that because of the 2H in H2S. So it becomes what? In total becomes 10 proton must be added to the product side. 8 because of the 4 H2O, 2 because of the 2 proton in the H2S. In terms of atom, let us count whether we balanced the reaction or not. How many hydrogen do we have? 8 plus 2, here is 10. How about here? 10. How many sulfur? 1 and 1. How many oxygen? 4 oxygen in the reactant, 4 oxygen in the product. That's how we balance the atoms in acidic medium. How about the basic medium, guys? To balance in the basic medium, add water to the higher oxygen side and hydroxide to the lower oxygen side. We added water and proton for the acidic medium, water to the lower oxygen side, proton to the higher oxygen side. But here is the reverse. We will add hydroxide with water, but water to the side of the higher oxygen and hydroxide to the lower oxygen. Why? Because hydroxide contains oxygen, it should be added to the lower oxygen side. How to add hydroxide and water? The same mechanism. Add H2O to the higher oxygen side equals to the difference between oxygen and from the reactant to the product. Add the hydroxide to the other side twice as H2O. So add twice as H2O hydroxide for the lower oxygen side. Let us balance this reaction, back to balance the reaction, guys. The 7th step which we follow, first of all, we have to write down the formula equation. Formula equation must be given. If it's not given, there will be a word equation transferred to the formula equation. So here the word equation is given. The word equation is given by what? Hydrogen sulfide and nitric acid to produce sulfuric acid and nitrogen dioxide and water. First step is to convert this into the formula equation. The formula equation, H2S plus the HNO3 formed H2SO4, NO2 and H2O. With the formula equation, write the overall ionic equation. What to do in overall ionic equation? Just only separate soluble salts, strong acids and strong bases. Do not dissociate or separate the oxides of carbon oxide, nitrogen oxide, H2O and weak acids with the molecular weak bases such as H2S, HF, NH3. We do not separate those groups of compounds of weak acids and weak bases with the oxides as well, but we only separate the what? The strong acids, soluble salts, and strong bases. In this case, H2S is weak acid, that's why we do not separate. HNO3 is strong acid, we ionize it, separate into H positive and nitrate. And then H2SO4 is strong, separated, ionized to form proton and sulfate. NO2, the oxides stay, and H2O stay as a molecule, as a non-separated molecules. Second step, so the first step is what? Always to write the formula equation, and then write the overall ionic equation, convert that formula equation into overall ionic equation. The second step, assign the oxidation number of all atoms in reactant to product. We assign it here, as you can see, the oxidation number of the all atoms in the reactant and product are known. In this case, we have to eliminate those species, compounds or atoms which their oxidation state unchanged, because after this stage we need those atoms or polyatomic ions or compounds which the oxidation state changed from reactant to product. Elements in which oxidation number does not change are deleted or eliminated. Hydrogen and oxygen, oxidation number didn't change and cancel it. So the hydrogen, here the protons, they do not have the changed oxidation number. Oxygen as well, they must be cancelled out. What the oxidation number changes? Have a look on the sulfur, -2 changes to what? To +6. So from -2 to +6, there is increasing in oxidation number. That's the oxidation half, which we talked about in the previous section. How about nitrogen? From 5, it changes to 4. Here we have got reduction. So just write those molecules or the compounds which the oxidation state changes. Here we have written those molecules and compounds with the oxidation number changes. H2S, NO3 negative, SO4 negative 2, NO2 are those species with the oxidation number changing. What to do next? We have to write the oxidation half, balance for the atom and the charge alone, and then reduction half, balance for the charge and atom, and then combine them together. Let us do the coming procedure, and then we will be talking about the other procedures. In this case, we have written the oxidation half. How to balance this oxidation half in terms of atom and then in terms of charge? As we talked about this note, guys, the medium is acidic medium. The medium is acidic medium. In acidic medium, we have to add H2O always with the H positive. How to add H2O and H positive? Always add H2O to the lower oxygen side, H to the higher oxygen side, And how many H2O must be added? Take the difference of oxygen between the reactant to product add the same amount of H2O, and twice H or proton as the H2O must be added to the other side. Have a look on this reaction. In this side we have got prior to the addition of H2 and proton, we have got 0S and then 4 oxygen. So we have to add 4 H2O to the reactant, which is the lower oxygen side, and then twice as that for 8 to the product side. But we added 10 because this 10 refers to the 2 plus 8, it becomes 10 proton in the product. In terms of the atom, it's balanced. How about in terms of the charge of the ion? It's not balanced. How to balance these guys? This process, as you can see, it's what? It's the oxidation. So you have to add electron in the product. Electron. But how many electron? Take the difference of the oxidation number from reactant to product, or total charge between reactant to product, you'll be able to know the number of the electrons. Let me test both possibilities, guys. From -2 as oxidation number to +6, -2 to 6, it's 8 units on the coordinator. So you have to add 8 electrons to the product. How to find or calculate from the charges, total ions? What we test the second way in order to determine the by total ions or the charges in the reactant to product. These are not the ions, these are the oxidation number, guys. So the total charge of the reactant is zero charges. They are both neutral compounds. How about the product? Here is a polyatomic is -2 plus 10. -2 plus 10 is 8. 0 to 8 as well, the same is 8 electron must be added to the product side. That's how we can balance for the charges as well. So we added 8 electron to the product. We have balanced the oxidation half for both atoms and charge. Let us balance the reduction for the atoms and the charge as well. How to balance the reduction half? The same procedure in acidic medium. Here we have got 3 oxygen in the reactant, 2 oxygen in the product. We have to add the difference, take the difference is 1 oxygen. Add H2O to the lower oxygen side. How many H2O? 1 H2O. And the twice as that to the reactant. How many H? 2H positive. In terms of atoms is balanced. How about in terms of the charges or the atoms, guys? Let me show you how to balance the charge. From 5 till 4 is what? Is 1 unit. 1 unit. What we have to add for the reactant? 1 electron. Why in the reactant? Because it's reduction. Why 1? Because the difference of the oxidation number is 1. How to balance the ion? We have balanced it in that way in terms of balancing the reaction. We added, sorry guys, we added 2 proton to the product, to the reactant. So here we have got -1, okay, -1, plus 2 is 1. In this 0, 1 till 0, the total charge in the reactant is 1. In the product, we have got 0 charges. I'm not talking about the oxidation number, the 5 and 4 are oxidation number. So 1 must be added to the reactant, 1 electron added to the reactant. This one is the balanced reduction half reaction. So first we have written the formula equation, overall ionic equation, assign the oxidation number, take those species which are oxidized or reduced, but take the oxidation half balance for the atoms and the ions. For the charges, take the reduction half balance for the atoms and the charges. The next step is what? Is to add those two halves. But when we are able to add those two halves, whenever the electrons lose it equals to the electron gained, we have to equalize those electrons. If not, multiply one of the reaction by the factories. Here we have combined both reactions. As you can see, 8 electrons lose it, but 1 electron gain it. How to equalize these two? Multiply the reduction half by 8 in order to gain 8 electrons. So here we have multiplied the whole reaction, 8NO3 negative, 2 multiply 8, 16H, 8 electron, 8 NO2, 8 H2O. The next step is to cancel any electron or ions or atoms which are able to cancel out. How to cancel? As you can see, 8 electron in the product cancelled with 8 electron in the reactant. The proton, 10 proton with 16 proton, only 6 proton remain. 4H2O with 8H2O, 4H2O is a remainder. And then, do we have any other things to be cancelled? No. So add these two together, you will get a reaction which is the addition of both halves. This is the what? The reaction of which represent the addition of oxidation and reduction half. What to do next, guys? We have to compare this with the main formula equation. In the formula equation, which ion, which atoms, species combined together, in which proportion we have to combine those atoms and ions in the same proportion. Let us do the procedure, guys. In this case, if some of the atoms are missing, we have to add to the reactant and product. So we have additionally atoms to the reactant and product. According to the formula equation, guys, H2S is H2S. So here we have got H2S, H2O, and NO2, 8 NO2. Those species which we did not dissociate or ionize into the ions, we write down the same without adding any amount. But we will combine those ions which we ionized or dissociated, we combine them, and if there will be a lacking of one of them, we add the amounts. In this case, guys, HNO3, we ionize it or separate into H and NO3. How many H reacts with the nitrate? For every nitrate, we need a proton. In this case, how many nitrates do we have? 8 nitrate. But how many H do we have? 6. So how 6 proton can be combined with 8 nitrate? Always try to increase the low amount to become to the same as the higher amount. In this case, what we have to do, add 2 proton to the reactant. As you add anything to the reactant, add the same to the product. So add 2 proton to the product as well. Second, the sulfate with the proton. How many sulfate exists with the proton? For every one sulfate, there should be 2 protons. So the sulfate, how many sulfates do we have? 1. How many protons we added? 2. Because of that, in the reactant we added 2. We added 2 protons. These 2 protons combined with 1 sulfate to form H2SO4. And then finally guys, we will get a reaction. As I told you, H2S, NO3, NO2, H2O, we have written without changes after the combining of the both halves. because we did not separate these compounds. 8HNO3, because we added 2H, it becomes 8H and 8NO3. H2SO4, 2H that we added with the sulfate combined to form H2SO4. Here we have got the balanced reaction. Here we have got the balanced reaction. And note, if an amount added to the reactant, the same amount must be added to the product, guys. You have to be careful about that. Whenever you add something in the reactant, add for the product. This is a figure represents the reaction between the KMnO4 titrated with the acidic solution of FeSO4. The purple MnO4 ions are reduced to colorless Mn positive 2 ions when all Fe positive 2 ions are oxidized. MnO4 negative ions are no longer reduced to colorless Mn positive 2 ions. Thus, the first appearance of the MnO4 negative color indicates the end point of the solution. That's the explanation for the figure. Let us balance an example in the basic medium. This example, this question in the, I think in the chapter review, question number 20, guys, said balance this reaction in basic medium, guys. This is the formula equation. Let us write the overall equation. PbO2 stay unchanged or non-separated. K positive plus Cl negative to form K positive plus ClO negative, and in this case, guys, let me write KPbOH by 3. How is the formation of this? Guys, KPb, they are both metals. K is positive 1, okay? How to be, the hydroxide is negative 1, you know that. What will be the Pb charge in order to get positive 3 here out of the bracket, or 3 out of the bracket? This should be positive 2 to add to the positive 1 of potassium to get positive 3. So in this case, K is positive 1, and then Pb is positive 2 plus 3 OH negatives. Guys, in order to, the next step is to assign the oxidation numbers. Oxidation number of, let me write by the green. Oxidation number of oxygen is -2, and then Pb becomes 4. K is positive 1, negative 1, positive 1. The oxidation number of the oxygen is -2. -2 multiply, -2 plus X equals -1. X is equal to the 1. So oxidation number of Cl is plus 1 in this case. K again is plus 1. Pb is plus 2. And oxygen -2, hydrogen plus 1. So what are the oxidation and reduction species? As you can see in this case, guys, Pb from 4 reduce it to Pb positive 2. So PbO2 goes to form Pb positive 2 in the product. How about it? This is reduction half. How about oxidation half, guys? Cl negative goes to what? To ClO negative, which is from -1, it goes to +1. From -1, it goes to the +1. So write down Cl negative goes to what? ClO negative. What to do next is to take each of the halves, balance for atom and the ions, but prior to that we have to know it's in basic medium. Basic medium, H2O, must be added to a higher oxygen side, OH must be added to the lower oxygen side. Don't forget this, guys. OH must be added to the lower oxygen side. Okay, let me just somehow write the halves. The oxidation half, let us take the oxidation half. Cl negative goes to form ClO negative. The oxidation number of Cl here is negative 1. Here is positive 1. This is oxidation. In terms of the atoms, do we have difference on oxygen number from reactant to product? Yes, of course we have difference. Here is 0, here is 1. Add H2O to the higher side. How many H2O? Equals to the number of the difference of the oxygen between the reactant to product, 1. How many hydroxide must be added to the other side? Twice as added H2O. Twice added H2O. So 2 hydroxide must be added to the reactant. Let us see if it is balanced or not. How many oxygen do we have? 2. 1, 2 in the product. Cl1, Cl1. 2H, 2H. This is balanced in terms of what? In terms of the atoms. How to balance in terms of the charges, guys? How to balance in terms of charges? To balance in terms of charges, -1 to 1 is what? Is 2 units. -1 to 1, 2 units. That 2 must be added to what? To the product. Why? 2 electrons must be added to product in order because it's oxidation half. It's what? It's oxidation half. For the total charges, guys, how many negative do we have? -2, -1, -3. In this side, we have got -3. About the other side, this is 0 and this is -1. Okay, from the -3, -1 to -3, we have 2 units in difference. That's why we add 2 electrons to the product. That's the oxidation half, guys. Let me just erase this part in order, to write the reduction half. The reduction half, for the reduction half, let us write the reduction half as well, is PbO2 to Pb positive 2. It goes to the positive 4 to what? To positive 2, which is reduction. You know, in the reduction, we have to write the electron in the reactant side. But first of all, let us balance the atoms. How many oxygens do we have here? 2. There, 0. The difference between oxygen in the reactant to product is 2, sorry. So add 2 H2O to the higher oxygen side, twice hydroxide to the other side. 2 H2O plus PbO2 goes to form Pb positive 2 plus twice as this 4 hydroxide to the product side, because it's basic medium. Let us check whether it's balanced in terms of atoms. 1 Pb, 1 Pb. 2O plus 2, 4. Here we have got 4. 4 hydrogen in the product. For the addition of the electron, how many electrons must be added? 4 to 2. We have to add 2 electrons to the reactant side. 2 electrons to the reactant side. In terms of the total ions, guys, here the total ion is 0. But here 2 minus 4 is 2. So -2. 0 till -2 is what? Is 2 units. That's why we add 2 electrons to the reactant. The next step is what? To test whether the number of electrons lose it equals to the number of electron gained. Yes, in this case, 2 electron gained, 2 electron lost. Then let us add both halves. Let us add both halves. Guys, we will add this with that half. 2 electrons in the reactant, 2 electrons in the product cancel out with each other. 1 H2O in the product, 2 H2O in the product, 1 H2O remain in the reactant, 1 H2O remain in the reactant. Here we have got 4 hydroxide in the product, there 2 hydroxide in the reactant, 2 hydroxide with 4 hydroxide, 2 hydroxide in the product. And then we write the equation. Cl negative plus H2O plus PbO2 are all in the reactant of both halves. Then Pb positive 2 plus 2 hydroxide plus ClO negative in the product of the both halves. In this stage, we have to compare this to the above. What dissociated or what separates, we have to take the same proportion to combine them together. What's not separated, as you can see, the PbO2 stay unchanged. So we will not change the PbO2 for any purpose. And then H2O format, which was not appeared in the above. We have to know how the H2O formed. Let us talk about for every Cl, which is formed here, Cl combined with what? With K. So 1 Cl remain, we have to add 1 K for the reactant, 1 K for the reactant, and 1 K for the product. Okay. You get what? KCl plus H2O plus PbO2 to form the reactant, the product, sorry. In the product, what do we have? We have got K with ClO, K PbOH by 3. This K we added with the ClO combined to form what? KClO. Okay. Plus, how many hydroxide in the structure do we have? 3. To form 1 KPbOH by 3, we need 3 hydroxide. Here, how many hydroxide do we have? 2 hydroxide. So add 1 hydroxide to the product. If you add 1 hydroxide to the product, don't forget to add for the reactant as well. Add again the 1 hydroxide to the reactant. How about how many Pb do we need? 1 Pb. Here we have 1 Pb, we do not add Pb. How about K? 1 K. Do we have more available Ks? No, we have to add 1 K as well. So when you add K for the product, don't forget to add the same for the reactant. So let us rewrite Pb with K plus 3OH will form K PbOH by 3. And then the ions must be combined. Don't let like that. K with OH, they will form KOH. The final form of the reaction, let me just erase this part in order to rewrite the final form of the reaction, guys. It's what? The final form of the reaction is KOH plus KCl plus H2O plus PbO2 to produce KPbOH by 3 plus KClO. That's the balanced form of the reaction. How many K in the reactant? 1 and 2. How many K in the product? 1 and 2. Pb, 1 Pb, 1 Pb. Cl, 1 Cl, 1 Cl. hydrogen 1, 3 hydrogen, 3 hydrogen, oxygen 1, 2, 4, 3, 4. That's the balanced reaction. This is somehow tricky because some new reactants and products appeared which were not appeared in the main or the formula equation, which like what? KOH in the reactant appeared, but here we do not have KOH. H2O as well appeared in the reactant. Here we do not have H2O in the reactant, which appeared in the balanced equation. That's how we balance the reaction in the basic medium, guys. Another reaction in acidic medium. This reaction I will be just showing as quick as possible. Copper with H2SO4, copper sulfate with SO2 and H2O. Write the ionic equation, assign for the oxidation numbers. Here the overall ionic equation, and then we assign it for the oxidation number, guys. As you can see, copper oxidized from 0 till 2 to 2. Sulfur reduced from 6 to 4. We will take just Cu positive 2, SO4 negative 2 to SO2 as those that change it in the oxidation number. The oxidation half, Cu, do you have any difference of oxygen from reactant to product? No. So it's balanced in terms of atoms. Whenever there will not be oxygen in the reactant and product, it's balanced in terms of atom. How many electrons must be added to the product? 2 electrons. Why? Because the 0 till 2, we have got 2 differences in oxidation number, or 0 till positive 2 as the charge, we have got 2 differences. Reduction half, in the reduction half, we have the difference of oxygen in the reactant to the product, which is 2. This is the acidic medium. In acidic medium, don't forget to add H2O equals to the difference of oxygen from reactant to product to the lower oxygen side. So in this case, 2 H2O added for the lower oxygen side, and then twice as that added proton to the reactant side. How many electrons must be added to the reactant? 2 electrons. 6 till 4 is 2 electrons, or summation of the charges, you get the 2 because here summation of charge is 0. For positive minus 2 is 2 till 0 is what is 2 electron must be added to reactant because it's reduction. And after that, add the 2 halves. When the 2 electrons are equal, add the 2 halves directly, you get this reaction. Then the next step is to add or compare this to the main equation. In the main equation, guys, the H2SO4, we have got H2SO4. For the H2SO4, every sulfate needs 2 protons. Every sulfate needs 2 protons. For the one sulfate, we need for one sulfate, we need 2 protons. How about here? We have got 4 protons. How many sulfate do we need? To form H2SO4, we would both add the 1 sulfate ion to both sides. Guys, as I told you, whenever 2 ions combined, try to increase the lower amount to become equals to the higher amount. To form one H2SO4, we need 2 protons and 1 sulfate. Here we have 1 sulfate with 2 protons. What will happen to other 2 protons? You have to add 1 sulfate in order to combine. So add 1 sulfate SO4 2 negative for the reactant, SO4 2 negative for the product. What will happen? We will get Cu plus 2 H2SO4 to produce. In the balanced equation, guys, Cu combined with sulfate. How many Cu combined with the sulfate? The 1 Cu with 1 sulfate. So CuSO4, we have got one copper and one sulfate. The sulfate that we added will combine with the Cu to form what? CuSO4. How about for the SO2 and H2O? We did not separate them, so we write them the same, SO2 plus 2H2O. That will be the balanced reaction for this reaction in the acidic medium. There will be questions in exam, guys, asking which of the following is the balanced oxidation half. So it's not required to balance the whole formula equation. Which of the following is the balanced reduction half? It's not required to balance till the end, the formula equation. It requires to balance only the reduction half. Or may ask how many H2O added to which side in the oxidation half. How many hydroxide proton added to which side in the reduction half or oxidation half? This should be asked for the purpose of ministerial exam, and those procedures not required to balance the formula equation. Just try to balance the reactions as much as it's possible. Here we have got so many other reactions, guys. The reactions are given and the additions. In general, this was the reaction that we have balanced. In general, guys, the procedure, we have to follow the mechanism as writing the formula equation, then assign oxidation number, and then balance, take the oxidation half, balance for the atom and the charge. Prior to that, you have to know to balance in which medium. In acidic medium, add H2O to the lower oxygen side, H for the higher oxygen side. In basic medium, H2O for the higher oxygen side, OH hydroxide for the lower oxygen side. And then when you balance both sides, the number of the oxygen which lost must be equal to the gained oxygen electron. If not, you have to equalize them and then add the two halves. The next step is the final step is to compare the addition or the summation of those two halves with the formula equation, which we will be adding some of the ions or species which are necessary. Critical thinking, it's the reaction as it's given. P4 goes to form phosphine PS3 plus H3PO4. This is an example of this proportionation which we will be talking about in third section. This proportionation is that when the same atom, which phosphorus in this case, reduce it to -3 in this case, and then oxidize it to +5 in the phosphoric acid. The same atom at the same time reduce it and oxidize it, recovers the disproportionation. It's required to find the mass of the phosphine by the mass of the phosphorus. First of all, we have to balance the equation. How to balance? This is a redox reaction. Let us balance by using the redox method. P4 goes to form PH3. In this case, we do not have oxygen in the system. That's why we do not balance according to addition of the H2O, and we will be balancing in acidic medium, but we do not balance according to the addition of the H2O and proton. Let us balance the phosphorus. How many phosphorus in the reactant? 4. Add 4 for the product. What happens to the proton number? In the product we have got 12 proton, so add 12 proton to the reactant as well. This reaction is what, guys? Is oxidation or reduction? Of course it's reduction, because 0 goes to -3, so that's why we have to add the electron to the reactant side. How many electron must be added to the reactant side? 0 to -3 is 3 units. How about this for one atom? How about for 4 atoms? 4 multiply 3, we have to add 12 electron to the reactant in order to balance the atoms. In terms of balancing, we have balanced the atoms and charges. In order to balance the charges, we have added the electrons. We added the balanced, we balanced the electrons in this system. Let us balance the second reaction, which is the oxidation. P4 goes to form H3PO4, or we can dissociate into PO4 and H3. The same PO4 3 negatives where the S3 will not be adding to the system. Okay, what we have to do first to balance the atoms. How many oxygen do we have here? 4. The 0. But prior to that, we have to balance the phosphorus. Phosphorus is 4. Here we have to add 4. 4 multiplied 4 is 16 oxygen in the product, 0 oxygen in the reactant. In acidic medium, you have to add H2O to the reactant, so you have to add 16 H2O to the reactant, and then twice as that proton to the product, 32 proton to the product. This is for balancing the atoms. How about in balancing? What to do for balance the charges? Guys, the oxidation number of phosphorus here is 0, here is 5. 0 till 5 is 5 units for one atom. How about for 4 atoms? It's what? It's 20. It's what? It is 20. That's why we can write the 20 electrons in the product of the reaction, because it's oxidation. Okay, guys, when we have these two, it's the both halves of reduction and oxidation half as well. Reduction and the oxidation half. Let us test whenever the number of electrons gained equals to the number of electrons lost. No, we have to find a conversion factor, or the factor between them, to equalize them. If we multiply the 12 by 5, we'll get 60, and multiply 3 by 20, you'll get 60. So by multiplying the above, the reduction half by 5 and the oxidation half by 3, we'll get the same number of loose or gained electrons. Let me multiply this half by 5. Let us use another color. Okay. 5 multiplied by 12, 60 electron, plus 5 multiplied by 12, 60 proton, plus 5 P4, and 5 multiplied by 4, 20 pH3. That's the balanced or the reduction half. Let us multiply the oxidation half by 3. 3 multiplied by 16, 48 H2O. 3 multiplied by 1, 3 P4, plus 3 multiplied by 4, not plus, goes to the product side, 12 PO4 negative 3, plus 3 multiplied by 32, it's 96 proton, plus 3 multiplied by 20, 60 electron. Okay, let us cancel the electrons. 60 electron cancel out with the 60 electron. Okay. 60 proton with the 96 proton, we have got 36 proton remaining. 36 proton is the remainder. What else can be cancelled? Let us see. This is or we can say 20 PS3. Here we do not have PS3. 48 H2O. طبعا there is nothing to be cancelled more. We have just one addition between the 5P4 with the 3P4. 5P4, 3P4, 8P4 plus 48 H2O. Okay, there is nothing more in the reactant side. Goes to the product to form what? To form in the product 12 PO4 negative plus 36 proton in the product plus 20 pH3, 20 pH3 in the product. In this case, guys, let us divide the reactants and the products by a factor in order to get the lowest possible coefficient. Let us divide all by what can be divided by 2. Let us divide by 2. 8 by 2, you'll get 4P4. 48 by 2 we'll get 24 H2O. 12 by 2 we'll get 6 PO4 negative 3. 36 by 2 we'll get the 18 H, and 20 we'll get 10 pH 3, which is the balanced equation in this case. But in order to balance the reaction, guys, what combine it with what? What combine it with what? The pH3 we stay unchanged, but for the number of the S3 and PO4, the S3 and PO4, for 1 PO4 we need 3H. For 1 PO4 we need 3H. How about 18 PO4 and 6 PO4 and 18H? You'll get what? 6 H3PO4. This will be what? A 6 S3PO4. Let me rewrite the reaction again. Of 4P4 plus 24H2O to produce 6S3PO4. We combine them plus 10pH3. That's the balanced reaction. Again, we can divide by 2 in order to get 2P4 plus 12H2O to form 3S3PO4 plus 5pH3. The last form of the balanced equation. Let us test whether it's balanced or not. 2 multiplied 4 is 8. So how many P do we have in the reactant? 8P in the reactant exists. How about here? 3P with the 5P, 8. 24 hydrogen, 3 multiplied 3 is equal to 9 plus 5 multiplied 3 is 15. It will be 24. 12 oxygen, 3 multiplied 4 is 12 oxygen. This is the balanced equation, guys. In order to how many this part eliminated in the Kurdish version, guys, but if you want, let us solve. It relates to the stoichiometry. Okay, guys, to convert the mass of P4, which is 56 grams, to the mass of phosphine, which is we don't know. First of all, we have to convert the mass of phosphorus into its mole, and then by taking the mole ratio to the mole of phosphine, and then mole of phosphine multiplied by the molar mass to convert to its mass. What's the molar mass of phosphorus, guys? For 4 phosphorus, we have got 124 as its molar mass. So the mass is given, mole of P4 is equal to its mass, which is 56 divided by 124 grams per mole. This will provide what? This will provide a number. Let us solve. We have solved it, but let me calculate. Here, 56 gram divided by 124, you'll get the result of 0.45 mole. So how many moles of phosphorus do we have? 0.25, 0.45, sorry. 0.45 mole is given. How to convert the mole of phosphorus into phosphine? By taking the mole ratio. 2p4, for every 2p4, we have got 5 phosphine, PS3. How about 0.45 will produce X PH3. Cross multiple both sides. 2X equals 5 multiply 0.45 is equal to 2.25. This divide by 2. X is equal to divide by 2. X is equal to 1.125. This is the mole of what? Mole of phosphine. The mole of phosphine must be multiplied by its molar mass, which is equal to 34. This mass of phosphine PS3 equals 1.125, which is its mole, multiplied by 34 grams per mole, which is the molar mass. So 1.125 multiplied by 34, you get the result of 38.25 mass, or the gram, for the phosphine. That's how we have calculated for the mass of phosphine. Guys, it's time to solve some ministerial exam question in section 2. Let us solve some of those questions. In a balanced equation, equation for the following redox reaction in acidic medium. So this is an easy type of question. We have to add these coefficients respectively to the above. For example, 1, 2, 2, 1, 1. This here 2, 6, 2, 5. So the first one is not true to be taken. Why? Because we have got 6 numbers, 6 coefficients, but there are 5 as the reactions and products. Take the second possibility. 1, 2, 1, 4, 3, 2. 4, 3, 2. It's not also. Let us take another possibility. The C, 1, 4, 1, 1, 2. How many Mn do we have? 1 Mn, 1 Mn. How many Cl? 4 Cl. Here we have got 2 Cl plus 2 Cl, 4 Cl. How many hydrogen? 4 hydrogen. How many hydrogen? 2 multiply 2, 4 hydrogen. Oxygen, 2. Oxygen, here we have got 2. So C is the correct coefficient, correct set of coefficients which we have used to balance the equation. The same type of questions in ministerial exam for the second question. Just try to take these coefficients into, these sets of numbers respectively into the above. When it balances the atom, you will be able to choose the correct answer. The third as well, it's the same mechanism. For the reaction, this reaction is given the balanced equation for oxidation half reaction only. So in this case, it's only required to balance the oxidation half. From the above equation, guys, it's obvious that oxidation number of sulfur is positive 2 and here is positive 6. This is the oxidation half. But H2S will produce, you have to ionize this or separate into SO4, 2 negatives. Okay, how to balance this? This is in acidic medium, guys. The number of oxygen in difference is 4. We have 4 oxygen in difference. We have to add the number of the hydrogen H2O to the low oxygen side, which is 4 H2O added to the reactant plus H2S to form SO4 2 negative plus twice as this proton, which is 8, but with the addition of this 2, it will be 10 proton to the product. About how many electron must be added to the product side? The positive 2 to positive 3, negative 2, it's negative 2. Negative 2 to positive 3 is what? Is the 8. So I add 8 electron to the product side. This is the balanced oxidation half. Which one represent the balanced oxidation half? 4H2O with H2SO4, sulfate 4H2S, yes, 4H2O, sulfate 10 proton and 8. This B is the correct answer. That's the balanced oxidation half. This is -2, guys, sorry, it's not +2. Let us solve this question to find the number of the electron lost in this process. We have got C2O4 -2 produce CO2. First of all, let us balance the carbon. We have added 2 carbon to the product. Here we have got 2 carbon, 2 carbon, 4 oxygen, 4 oxygen. There is no difference in the number of the oxygen. The total ions in the reactant is -2 and total ion in the product is 0. So the -2 to 0, how many electrons lost? 2 electrons lost in the process of this reduction reaction. Balance the this half reaction in basic medium. In basic medium, let us balance the half reaction, guys. MnO2 produce Mn2O3. What happens to the Mn, guys? Mn is this is oxygen is -2. It will be 4 plus 4. In this reaction, it is 4. How about the other -2? It will be -6 plus 2x becomes 0. Okay, 2x equals 6. X is equal to 3. Here the oxidation number of Mn is 3. The Mn 4 goes to the 3, that means it's reduction. So in the reduction half, prior to the charge, we have to balance the Mn, guys. Add 2 Mn to the reactant. Okay, when we add 2 Mn to the reactant, it balances the Mn. About the number of oxygen becomes what? Becomes 4 in the reactant and 3 in the product. Okay, guys. Let us solve or balance the atoms. Let us balance the atoms. Guys, if you do not add this 2 Mn, represents the, you will not be able to know that the number of the higher oxygen is in the reactant. You may count the number of the higher oxygen is in the product. That's not the case. Okay. What's the difference between the oxygen? Here we have got 4 oxygen. Here 3 oxygen. So in basic medium, H2O must be added to the higher oxygen side. How many H2O we have to add? The difference is 1 H2O. How about hydroxide? 2 hydroxide for the other side. To balance the atoms, guys, we have balanced the atom. To balance the charge, in order to know what happens to the charges, here we have got we can take the summation of the total charges and also the differences in the oxidation number. Guys, this here 2 multiply 4 is 8. Okay, 2 multiply 3 is 6. 8 to 6, we have got 2 differences in the oxidation number. So add 2 electrons to the reactant side because it's reduction. That will be the balanced reaction. So 2MnO2 plus 2H2O plus 1 electron, no, 2MnO2 plus H2O plus 2 electron, Mn2O3 plus 2OH is the correct answer. This is B, is the correct answer. The other question in this reaction, after balancing oxidation half reaction in acidic medium, the number of water molecules will be, so you have to balance the reaction till the end and then define the number or calculate the number in the oxidation half. Let me solve it, guys. Let me solve it. 0, positive 6. This is the oxidation. So S goes to SO4, 2 negatives or negative 2. In this case, 0 goes, sulfur goes to the positive 6. Positive 6 to 0, it's what? It's 6 electrons. But prior to that, let us balance for the atoms. How many oxygen do we have in the product in the reactant? 1. So what we have to add for the reactant? 4H2O. 4H2O. And then for the product, we have to add twice as that, 8H positive. So it's required to what? To find in acidic medium the number of water molecule. It's 4 water molecule added to the reactant side. C is the correct answer. That's how we have solved the Ministry of Exam question. Thank you for the attention, guys. That's the end of the session.